Hi, welcome back to part 2 of our Power Mosfet journey. To bring you up to speed, what we got here is a control technique for a Power Mosfet. It's the P-type. And so this would be going to the gate of the P-type. This is simply going to the 45 volts. Now the gate in question also has a source. Let's try to draw a Power Mosfet here. I think they do something like, I don't think I draw this very well, but there's your gate. Let's connect it. Right, here's a Power Mosfet with a protection diode. Alright, they're kind of drawing it like that. Okay, and then they come out and they got your protection diode, which in the P-type material would be faced that way. The Zener diode from International Rectifier, which unfortunately looks like somebody has bought them out. Oh, woe is me. And then that goes on to power something, provide 45 volts for that would be the drain. This would be the source. So can we get this? Oh, source we're going to connect to 45 volts. Let's just connect it there. Good. Okay, now can that 45 volts reach the drain? It can if you provide a voltage somewhat less than 45 on the source. To fully open this, so 35 volts would fully open, because that would be 10 volts down from what you're seeing it there. 10 volts negative down will then open the conductance up to go on through. And something ain't right with that diode. Oh no, it's fine, because the drain would then have, let's say, you probably have the 0 volts. Something that draws, something needs power, whatever that is. In this case, it's the coil in the 3-phase motor. And then you go to your drain. So the electron flow would be that way. Okay, that's not going to go. So it is a protection diode. If, of course, if you went in the other direction, the electrons would flow after simply a 0.6 volt, overcoming 0.6 volts. So, however, when the electrons are trying to go that way, no, it won't go through there. It'll have to wait till this becomes conductive. The metal oxide something, field effect transistor. So we're putting a field of, yeah, so the gate is like high ohms between here and there. Like it's not connected, it's just doing a field, electric field, to change the behavior of the conductance of that. Okay, how can this circuit, okay, what if we go back and put 0 volts? If we put 0 volts on this transistor, that means it'll be a 0.6 or 7 volt drop across here. Well, let's just say if you're forcing that to be 5 volts by hooking it up to a 5 volt power supply, then some current will flow through here. We don't know yet, an unknown amount of current, but this will have a 4.3 volt reading with your voltmeter. All right, let's figure out the current. This is a 500 ohm, or actually 475 ohm. Let's see if we can do the math. And I don't have my calculator nearby. So, a certain amount of current will keep flowing through here until you'll get a reading of 4.3 volts here, which means, okay, what's the Ohm's law? Resistance equals how many volts you need to force some current through there. So if this is 1 amp and you need 10 volts to force 1 amp, you're going to get 10 over 1, which would be 10 ohms. Now in this case we have, let's round it out to 500. Our voltage is 4.3. So if we rearrange that, we get 4.3 over 500. That would equal our current. Great. So we're going to come up with some value of like 0.01 amps, I think. And now up here we have a 2000. Let's make sure of that. Yeah, okay, 2K. 3 drivers, 2K, and all identical, 2K. So now we can work backwards to say, okay, got a 2 kilo ohm resistor, and we got 0.08 or something. Maybe, well, I'll let you do the math there. So do the math for me. 4.3 divided by 500 gives what amount of current flow? And then you can use again the Ohm's law. You know the resistance. You now know the current through it because the gate is not supposed to draw any current. And you can calculate the voltage drop across that resistor, which turns out to be pretty close to 20 volts when I did it. So that is the end of the big story thing I'm trying to point out here is due to a baby logic signal from a computer of going between 0 or 5 volts can go up and drive a p-type power MOSFET sitting at 45 volts, and it allows you to either put 45 volts at the gate. That's when this is set to 5 volts. 5 volts here, 5 volts here. Trying to overcome a 0.6 volt or 0.7 volt voltage jump. It's not going to happen. No current flows, and then no current will then flow that way. That's the theory of the transistor. You know, you draw a little current through the base, which causes maybe 100 times more current to flow that way. So it amplifies the current flow. But in this case, we're limited not by the transistor properties, but by these other resistors placed here. Okay, just by getting I never mentioned gain. I just was talking about, okay, if we did put that at 0, a certain amount of current flows. Whatever the current flows here, it's always going to be a 4.3 volts here, because this has like a diode behavior. Diodes are not really related to how much current flows through them. They always have a 0.6 volt drop. Likewise, the emitter to base is like a diode. It's just a diode that also provides leakiness. So when some current flows here, 100 times more current flows that way. Alright, so when I did the calculation, knowing its resistance, knowing the current flow through there, you can then calculate the voltage, and it came out to something like 25 volts, or 20 volts. So 20 volts from a 45 volt side down 20 would bring that to 25 volts. And that's just close to the limit of what the spec sheet says this p-type power MOSFET can handle. But the comment is the p-type MOSFET is less conductive. You know, if you have a given voltage, all right, the n-type, you can drive it with straight up 5 volts. The p-type, you need like 10 volts, and it can go up to 20, so what the heck? It's rated to handle 20 volts, more voltage, more conductance, and that's what this thing provides. Okay. Back to the hot plate in question. See if we can identify some safe. Alright, so hot plate in question. What was burned out on this? Looking at the microscope and also using the ohm meter, R330 was blown. It's acting like a fuse. It's R330 means 0.33 ohms. It's all the amps that are going out to the motor coils have to go through that. The circuitry had it winding to the bottom and then it back up. At first it didn't seem logical. Why wouldn't that just be connected directly on the actual circuit board? You see why wouldn't they take that capacitor, connect it directly to that side instead of looping around? Well, they did that because it makes this more close to then go out to each of the 3 power MOSFETs drivers. Each one of these is a double MOSFET, a P-type and an N-type. Well, that was blown. In other words, it was not reading 0.33 ohms, it was reading a few mega ohms or even an overload on my ohm meter. That was blown. That means I gotta go hunt that up and buy it. This resistor had burned, it got hot enough to burn the numbers. You couldn't read the numbers. However, because we had some nice identical circuits, I could get the number of the resistance. The 475 burnt resistor had increased its ohm, which is good. It increased instead of decreased to 2,000 ohms or so. Also, the resistance between the gate and the source was 0 ohms. So this little fella is blown. Got to replace that, and that. And hopefully I'll get me a working hot plate. Now, just as a little, of course, these come from eBay. Let me walk back into the other room while I'm chatting. And the guy said, of course, this told me what's wrong. It's just not stirring. And then he said, it could be just an easy fix. Anytime a seller says something like that, beware. Somebody had been in, obviously, if you just have one screw that you need to take that side loose, and they put a nice X, the mark of death for amateur, or, yeah, this had been checked out. And I'm a hobbyist. The difference between a hobbyist and a professional tech that has to crank out a repair is I spent a whole, doing a little bit at a time, I spent a whole week looking under a microscope, sketching the drive circuitry out, studying the data sheets, going to the website of EBM Pabst to see what's going on with the motor, and using a ohm meter to, like, you see when it goes from one side of the double-sided circuit board to the other, they got these like grommets, whatever you want to call them. To trace down the wiring, I would have to like hold it here and hold the circuit board vertically and go to the other side and look where it's going in order to come up with this. Yeah, so you have to have a lot of free time. So if you're confined to your home because of a coronavirus outbreak, go ahead and order yourself a as-is parts. Well, better not. You might go broke. These came out to be about $60 to $90 each with shipping. Alright, I just ran out of things to say. I hope you enjoy fixing your hot plate. Good night.